Hello students, Mr. Madison here with a video key for you. This that you see before me on the table is your practice number 4 on arc length. It contains 6 problems, and once again I'm going to demonstrate for you how to do each of these 6 problems. This will be the last practice before your quiz on arc length is posted, and you could reasonably expect to see problems like this on your quiz. So without further delay, we'll go ahead and get started. I'm going to read to you problem number 1. Problem number 1 says, the bicycle wheels have a diameter of 26 inches. So that means that this distance all the way across the wheels here is 26 inches. If the wheel rotates 100 times, how far will the bike move? Here's what you need to understand. As this wheel turns, the bike moves. So this circular motion of the wheel turns into a linear motion of the entire bike. And every time the wheel goes around one rotation, the bike would move a distance that's equal to the circumference of that wheel. So the distance then that the bike will move is going to be equal to the circumference of the wheel times 100, because the wheel's going down 100 times, around 100 times. So I'm just going to say 100 times the circumference. And the circumference would be pi times the diameter, which is 26 inches. So when I do this calculation and I get my answer here, my answer is going to be in inches. However, the problem specifically asks that we get our answer rounded to the nearest foot. So the first step is to do this calculation. Once we have that number of inches, we'll divide by 12 to change to feet. So I'm going to go to my calculator, and I'm doing 100 times pi, I'm just hitting the pi button on my calculator, times 26 inches, and I'm coming up with 8,168.14 inches. And if I take that number and divide by 12 inches in every foot, I'm going to get the number of feet. So I'm dividing by 12, and I'm getting 680.68 feet. The problem says round to the nearest foot. That's the specific instruction. So 680.68 would be 681 feet. And that's my answer for problem number 1. Problem number 2 reads, an electric winch is used to raise and lower heavy objects. So this circle spins, and when it rotates, this cable would wind around the spool and cause the object that's on the floor to raise up. A motor turns the winch, and the steel cable winds around the spool. If the spool turns 240 degrees counterclockwise is going to be this way. And you can see that if this rotates this way as I'm gesturing, that box is going to go up. How high above the floor will the box be? You need to see this problem as an arc length problem. Consider this point right here. I'm just going to put a point right here. When this point moves around the circle, it's going to move a distance that would be equivalent to the distance that this box rises. So very simply, we're just going to find an arc length. And the arc length for this problem, which would be equivalent to the distance that the box rises, is going to be the degree measure of the rotation, which is 240, divided by 360 times 2 times pi times the radius, which is given as 10 inches. So at this point, we just have a calculation to do. I'm going to go to my calculator and do 240 times 2 times pi times 10 divided by 360, and I'm coming up with 41.887 inches. The problem specifically says round to the nearest 0.01. So my final answer that I'm going to write down, because I want to get this right, is 41.89 inches. So that's your answer to problem number 2. All right, problem number 3. Problem number 3, we have ourselves a clock, and it says the radius of the clock is 14 inches. If a bug crawls along the outer edge of the clock from 10 to 12, the long way, how far will the bug crawl? Once again, this is an arc length problem. Let's start by kind of filling in our clock here with the missing numbers. That would be 10, 11, 1, and 2, 4, 5, and then 7 and 8. And it says the bug is going to crawl from the 10, so the bug is starting right here. I'm going to put the bug there. From the 10 to the 12, the long way. So the bug is going to go from the 10 all the way around to the 12. So this is the path of the bug that I'm scribbling on the outer edge of this clock. This is the path. First thing we need to do is determine how many degrees that is. Well, look, folks, on a clock there's 12 numbers, and all the way around the circle is 360 degrees. So if you take 360 and divide by those 12 increments, each increment will be 30 degrees. So from 10 around to 12 this way would have to be 300 degrees. Think about that. You've got 30 degrees between every two numbers. So from 10 to 11 would be 30 degrees. From 11 to 12 would be 30 degrees. So from 10 to 12 would be 60 degrees, which means that from 10, the long way around to 12 would be 300 degrees. So when I'm finding the arc length here, the number that I put in my numerator is going to be 300, because the bug crawled through a 300-degree arc on its trek from 10, the long way around, to 12. Divided by 360 times 2 times pi times the radius, which is given as 14 inches. So I'm going to do a calculation. I've got 300 times 2 times pi times 14 divided by 360, and I'm coming up with 73.303 inches. The problem says round to the nearest 0.01, so my final answer is going to be 73.30 inches. Problem number 4, we have two circles side by side. The two circles are actually what we would say tangent to each other, which just means they're touching in this one point right there. Now this is the center of this circle on the left, and this is the center of the circle on the right. And we're told that from A to B is 40 inches. So from A all the way across to B is 40 inches. Well, we know that in a circle, all the radii are the same. So this segment from A to B has been divided into 4 equal parts. So that means each part is 10. So the radius of each of these circles is 10. A bug crawls from A to B following the path indicated by the arrows. So this is how the bug's going. It's going around this half of this circle, then it's jumping over to the other circle and going around this half of the other circle till it gets to point B. As I look at this, it seems that if the bug travels that path, half of the circle on the left and half of the circle on the right, but the two circles are the same, that it really, the bug would have traveled once around the circle. So half of this circle plus half of this circle would actually just equal one whole circle. So the distance that that bug crawls is just going to be equal to the circumference of the circle, which is found by doing 2 times pi times the radius, which is 10. I'm going to go to my calculator and do 20 times pi. And I'm getting 62.831 inches. It says round to nearest 0.01, so my final answer is going to be 62.83 inches. Now, in problem number 5, unlike problem number 4, you have circles of different size. So the radius for the circle on the left is 15 inches, while the radius for the circle on the right is 12 inches. A bug crawls from A to B following the path indicated by the arrows. So the bug's going to start here at A. It's going to travel around the circle here till it gets here. Then it's going to jump over to the smaller circle and travel here. You need to see this as an arc length problem. Furthermore, you need to see this as an addition problem. And here's what I mean by that. We're going to find the arc length from A around to this point on the big circle. Then we're going to add that to the arc length from this point to this point on the little circle. It looks like the B's actually missing there. I hope that didn't confuse anybody. You just followed the arrows. So here we go. This arc length here is going to be a certain fractional part of the circumference of the circle. If this is 120, this arc right here is 120, then the major arc for this circle would have to be 240, which you get by doing 360 minus 120. So the distance that this bug crawls is going to be this arc length, which would be 240 divided by 360 times 2 times pi times the radius of that circle, which is 15. That would be this distance, once again, starting here at A and going around this 240-degree arc to this point. Then we're going to go over to the other circle, the smaller circle, and we're going to find that arc length and add it to the arc length that has already been traveled on the big circle. This is a 90-degree arc, so I'm going to have 90 over 360 times 2 times pi times the radius of that small circle, which is 12. I can do this calculation in one step or as one calculation. As long as I just enter it as I see it, left to right here, I'll be following order of operation pretty much. So here's what I'm going to do. I'm going to do 240 times 2 times pi times 15, and I'm going to divide all that by 360. Then I'm going to add to this over here. If you want to do this in steps, that might be better for you. I don't know that it matters a whole lot. So I'm going to have 240 times 2 times pi, hitting the pi button on my calculator, times 15, and then I'm going to divide that by 360. And you know what? I'm going to go ahead and hit enter. So I figured out this right here to be 62.83. I'm going to go ahead and do this as a separate calculation. This might be better what I'm showing you now to do it in 2 parts. So I'm going to do 90 times 2 times pi times 12. And divide by 360. And I'm coming up with 2 times pi. I'm coming up with 18.85. Then my final answer is going to be what I get when I add those together. So I'm just going to go ahead and add those together and get 81.68. Let's rerun this problem. Make sure everybody follows how to do it. It's really 2 arc length problems. You're going to find the arc length of this 240 degree arc. You're going to find the arc length of this 90 degree arc, and then you just add them together, and you'll be done. Problem number 6 is a similar problem. The bug crawls from A to B, so the bug crawls through this 45 degree arc on this bigger circle with the radius of 33, and then the bug crawls through this major arc here on the smaller circle. You know, this arc right here is 135. So this major arc on the small circle has to be 360 minus 135. And I think that would be 225 degrees. So here we go. The distance that the bug travels is going to be 45 out of 360 times the circumference of this big circle, which would be 2 times pi times the radius, which is 33. When I do this calculation that I've written down right here, this expression, that's going to give me the distance from here to here, as I'm gesturing, from here to here. I'm going to need to add that to the length of this major arc, this 225 degree arc. So I'm going to have 225 over 360 times the circumference of that big circle, that small circle rather, which would be times 2 times pi times the radius, which is 27. My answer is going to be in inches. So I'm going to do the calculation. Hopefully I'll come up with the exact same value you came up with. All right, let's see. For the first part here, I'm getting 25.92. For this second part here, I'm getting 106.03. And when I add those together, I'm getting a final of 131.95 inches. We'll very quickly review this problem too. This problem is really 2 arc length problems. You find the arc length of this 45 degree arc on this circle that has a radius of 33. You find the arc length of this 225 degree arc on this circle that has a radius of 27. And then you add those two together, and that's what I'm coming up with. So this then is a complete key to your practice 4 on arc length. And as I mentioned at the outset, you would certainly expect to see problems like this on your quiz. Students, thank you for your attention. I hope this was helpful for you. You all have a great day.